Hey, welcome. Today we're going behind the scenes into the world of the clinical laboratory. This is a place where every single detail matters, where precision isn't just a nice to have, it's literally a life-saving necessity. We're going to open up the special toolkit these labs use to make sure every result is rock solid, because when it isn't, the consequences can be absolutely devastating.
I mean, really, just stop and think about that for a second. What if that one number, the one your doctor is relying on to figure out what's wrong, to pick the right medicine, to save your life, what if it was just flat out wrong? The stakes really don't get any higher than that. And to stop those tragedies before they even start, clinical labs see quality improvement as way more than just a corporate buzzword. No, for them, it's an active, everyday mission to build systems that are so strong, so robust that errors are literally designed out of the process. It's all about protecting every single patient who depends on their work. To pull this off, labs have this powerful quality toolkit. We're going to dive into 6 of the most important tools they use. We've got benchmarking, root cause analysis, Lean, Six Sigma, FMEA, and DMAIC. Now, each one is designed to solve a different kind of problem, but together, they create this amazing system for patient safety. So let's grab our first tool, benchmarking. Okay, so first up is benchmarking. The idea here is actually pretty simple, but it is so powerful. Basically, you can't really know how well you're doing if you're just working in a bubble. So benchmarking is kind of like checking your car's miles per gallon against what the sticker said it should be. It gives you this objective outside standard to measure yourself against, and it tells you right away if you're crushing it or if you're falling behind. Let's see how this plays out in the real world. A hospital lab realized their urgent test results were taking about 55 minutes. But then they benchmarked themselves against a national survey and found out other labs like them were getting it done in just 30 minutes. Whoa, that 25-minute gap was a huge red flag. So they got to work, streamlined their process, and managed to slash their time down to 32 minutes, which is a massive win for doctors and their patients. And this is the whole point, right? Benchmarking doesn't actually solve the problem for you, but it's fantastic at pointing out that a problem exists in the first place. And it gives you a clear target to aim for. It's that essential reality check. But, okay, once you know you have a problem, you need a different tool to figure out why it's happening. And that leads us right to our next tool, root cause analysis, or RCA. Honestly, you should just think of this as pure detective work. RCA is all about digging past the obvious clues to find that one single underlying reason a problem keeps happening. And one of the best ways to do this is with a technique called the 5 whys, where you literally just keep asking why until you hit rock bottom on the issue. Check out this case. It shows you just how powerful asking why can be. A lab suddenly saw a big spike in dangerously high potassium results. So, first question, why? Well, the blood samples were getting damaged. Okay, second question. Why were they getting damaged? Turns out the phlebotomists were using the wrong kind of needles. And the final critical question, why were they using the wrong needles? Because there was no standard policy for which needle to use. In just 3 questions, they realized the root cause wasn't a bunch of individual mistakes, it was a broken system. They fixed the system and poof, the problem disappeared. And that's really the big lesson from RCA. It stops you from wasting time and energy just putting band-aids on the symptoms. Instead, it forces you to find and cure the actual disease lurking inside your process. The goal is always a permanent fix, not just a patch that'll fall off next week. Now, our third tool, Lean, comes at things from a totally different angle. It's not so much about fixing a single error, but about making the entire process faster, smoother, and way more efficient. The big idea with Lean is to be relentless in hunting down and getting rid of anything that doesn't add value for the patient. And this waste, as they call it, can be anything from extra useless steps to just wasted time walking around. For instance, one lab mapped out its workflow and had this aha moment. They realized their staff was spending a crazy amount of time just walking back and forth between the blood draw station and the centrifuge. That's pure non-value added waste. And the solution was so simple it's almost funny. They just moved a centrifuge right next to where they needed it. And the result? They cut their turnaround time by about 40%. Incredible. This absolute focus on value is the real heart of Lean. If a step in the process doesn't make the final test result better, or faster, or safer, then it's a target for elimination. And what's cool is that this doesn't just speed things up, it actually makes the work easier and less frustrating for the staff too. So while Lean is all about speed and cutting out wasteful steps, our fourth tool, Six Sigma, is all about precision and cutting out wasteful variation. Six Sigma is this super data-heavy method that basically declares that inconsistency is the number one enemy of quality. Why? Because when a job is done in a bunch of slightly different ways, you get unpredictable results and errors, which Six Sigma calls defects.
Here's a perfect example. A lab was struggling with a 4.5% contamination rate for its blood cultures, which is a really serious problem. So they tackled it like a Six Sigma project. First, they clearly defined a contaminated culture as a defect. Their data analysis showed that the root cause was all the variation in how the blood was being collected. So what was the fix? They completely standardized the process. New kits, new training, they made sure everybody did it the exact same way every single time. And the result was just a massive drop in that defect rate, all the way down to 1.2%.
So what kind of standard is Six Sigma actually aiming for? Well, this. To say a process is at a Six Sigma level of quality means it is so incredibly consistent that it produces fewer than 3.4 defects for every 1 million times you do it. Yeah, you heard that right. It's basically a push for near perfection. Okay, so all the tools we've looked at so far are fantastic for fixing problems that already exist. But what if you could stop problems from ever even happening? Well, that's the job of our fifth tool, Failure Mode and Effects Analysis, or FMEA. This is a totally proactive tool. It's like doing a pre-mortem on your process, where the whole team gets together to ask, what are all the ways this could possibly go wrong? And to do this in a structured way, they calculate something called a risk priority number, or RPN. You can see the formula here. For every potential failure they can think of, they score how severe it would be, how likely it is to occur, and how hard it would be to detect. Multiply those together and you get one number that instantly tells you which risks are the absolute biggest priorities. It lets them focus on preventing the worst-case scenarios first.
Think about how powerful this is. A hospital wanted to make blood transfusions even safer. So, during their FMEA, they identified drawing blood from the wrong patient as a potential failure with a catastrophically high risk score. So, before it could ever happen, they designed a fix, a brand new protocol that required a 2-person check and barcode scanning right at the patient's bedside. They proactively built a safety net, and that is the ultimate goal of FMEA.
Okay, on to our final tool. This one is called DMAIC. And it's not so much a single tool as it is the master framework that organizes the entire investigation. It gives you a structured, 5-phase cycle for solving really complex problems. DMAIC stands for Define, Measure, Analyze, Improve, and Control. It basically provides a roadmap for your quality improvement projects. You start by defining the problem, then you measure how bad it is right now, you analyze the data to find the root cause, you implement an improvement, and finally, this part's key, you control the process to make sure the fix actually sticks. So here's DMAIC in action. A lab defined its problem. Mislabeled tubes were causing delays. They measured the error rate and found it was at 2%. Their analysis revealed that the causes were a confusing workflow and labels that looked too similar. So they improved the process by bringing in barcode scanners and pre-printed labels. And finally, they put a control in place by constantly monitoring the rate, which dropped tenfold to just 0.2%, and, more importantly, stayed there. Problem systematically solved.
So let's put our whole toolkit together. You use benchmarking to figure out where you stand compared to everyone else. You use root cause analysis to dig down and find the real why behind a problem. You use Lean to get faster and more efficient by cutting out waste. And you use Six Sigma to get more precise by cutting out variation. You use FMEA to look into the future and stop problems before they can start. And you use the DMAIC roadmap to guide you through the trickiest challenges. Each tool has its job, and together they make an incredible system for keeping patients safe.